We are now in the screen that summarizes all the main measurements done with the wave analyzer. This is the summary screen. The wave analyzer provides the objective refraction the patient needs during the day and the objective refraction the patient needs during the night. It is information related to day and night refraction. It gives indication of the addition the patient may need at the chosen working distance, which was, in our example, 40 centimeters. Here we can see the information about the profile of the cornea. Here are the measurement of the thickness of the cornea. Finally, we see here the value of the intraocular pressure. Let's start with the eye wellness process to make sure patients' eyes are healthy. In order to do that, we'll first take a look at the retroillumination, that is a black and white image of the crystalline lens. We are checking the transparency of the lens and if there is presence of black dots or black shadows. In this image, the crystalline lens looks perfectly clear. The image doesn't look like an image that is displayed in the logs tab, thus cataract is not suspected. Indeed, LOX grades cataracts and means lens opacity classification system. In a second step, we will take a look at the values of the intraocular pressure. Our values are normal, between the standards. Finally, in a third step, we will take a look at the profile of the cornea. We will focus on the elevation map of the cornea and check the presence or not of red area in the center. By this way, we are checking if there is any potential keratoconus developing in the surface of the cornea. Everything looks perfectly clear on the right eye and on the left eye as well. As a complementary, we can check in the cornea tab the KPI value that indicates the keratoconus probability index. Now let's find potential insights to be more effective in the dispensing area. The wave analyzer provides vision simulation. The device is able to simulate the vision of the patient, both with and without glasses, but also according to different lighting conditions. We will show to the patient how he perceives letters without glasses and how well he will perceive letters with glasses. Now, what is far more interesting is to compare the simulation of vision of one eye in two different lighting conditions. In this case, we will show to the patient the difference between day and night vision on his right eye. What we can see here is that during the night, the patient has a blurrier vision than during the day. In that way, we can acknowledge his complaints regarding night vision issues. Let's move on to the information related to light sensitivity. We have to look at aberration values of RMS. In blue, we have the RMS value throughout the day and in purple throughout the night. We can see a significant gap during the two lighting conditions. This gap means that the patient is more subject to glare and halos. Therefore, we can provide to the patient a specific visual solution for driving during the night that will help him to see clearer. We can provide also specific coatings and lenses that will remove halos and glare he can experience from the lights of the incoming cars when he is driving, for instance. In a second step, we'll take a look at the accommodation that was measured by the wave analyzer. What we can notice here is that the patient was not able to fully accommodate at the distance of 40 centimeters. For this patient, a small addition value will be necessary to help focus properly during near vision activities. For instance, when the patient is looking at the screen of a computer or the screen of a smartphone. The results on the screen highlights the fact that he can no longer focus properly. He will need an extra correction in near vision in order to relieve the effort of extended accommodation and decrease the visual fatigue. In a third step, what we can see here is the cornea of the patient. What is very interesting is that we can see the visual axis in yellow and the pupillary axis in blue. There is a small decentration between the two lines. If we click here, we will look at the decentration represented by the kappa angle, which is the difference between the visual axis and the pupillary axis. In this case, because of this value of decentration, it will require to take more enhanced measurement to fit lenses that will remove decentration. Hence, we can provide to the patient personalized solution that will ease adaptation. It is possible to promote to the patient very high-end and personalized lenses. To finish, we can also take a look to the usual topography maps that the corneal topographer delivers. With all the information related to the profile of the cornea, it will be possible to potentially fit the patient with contact lenses.